So, is there anything we can do to overcome this lying? And this happens, you know, some people, it's very difficult. You know, you can't say, oh, divide by 80% or something and you'll get the truth, because people go in both directions. So people who think, for example, in some of these nutritional study, people think they're too thin will tell you that they've eaten more than they actually have. People who think they're overweight will tell you that they've eaten less than what they actually have. So it's very difficult to ex post compensate for lying. But here's one device that was introduced in the 50s. So the idea is this: you ask the person a question and then tell them, well, here's a device, it's a randomized device, and I can't see what it does. You are the only one who can see the outcome of this. What you do, after I've asked you a question, what you do is you spin. You spin this thing. If the arrow is in this area here, then tell me the truth. If the arrow comes in here, in this slice up here, in this pizza slice up here, just say yes to me. So if you say yes to me, if I ask you an embarrassing question, and you say yes to me, I don't know if you're saying yes to me because that's the truth, or whether you're saying yes to me because the pointer told you to say yes. Hopefully, using this will induce you to tell the truth, because I don't know if you're telling me the truth or whether you're just doing what the pointer tells you to do. So now, as a statistician, I'm interested in the aggregate. I don't care you individually, whether you're in the yes group or in the no group. All I care about is what is happening on average, the aggregate behavior. Okay, so some of you will look at this and think of this. This is a measuring device with a sensitivity which is less than 1, or a specificity less than 1, depends which way you're looking at things. And indeed, that's what it is. We're introducing some imprecision, hoping to gain some veracity. So, for example, if we look at this, if we ask n people, if the area of yes is A, and we ask n people, then NA of them will answer yes, just because the pointer told them to answer yes, and the other n1 minus A will give us truthful answers. Okay? If the total area is equal to 1. So it's like your Venn diagram all over again. All right? Then what we can do is we can do exactly as we did with the testing and classification, etc., when we looked for people with TB. And what we get is that finally, of the people who answered yes, say there's m of them, then NA of them will be the ones who answered yes because the pointer told them to. And of the n1 minus A who are going to tell us the truth, then we will get the proportion, theta, from those, and we multiply that. And we can solve this to give our estimate, and there's the estimate from this. We look at the proportion who said yes, subtract A, and divide it by 1 minus A. This looks exactly like the formula we had for estimating prevalence. Okay, there it is. The advantage, we hope, is that this lessens the lying fraction. Disadvantages is that it increases the variability. Okay, but with respect to what? With respect to the idealized one, which doesn't exist, which is when everybody tells you the truth. And the other thing is that it's costly. It's difficult to use in a mail survey, for example. It's difficult to explain, and you introduce all sorts of errors. But it has been used. I'm surprised it hasn't been used more often. It has been used. It was used in a phone survey in 1986 where the person was asked, okay, before I ask you the question, get 3 pennies and spin these coins. So spin 3 coins. Now, if you get 3 heads, you say yes to me. If you get 3 tails, you say no to me. If you get any other, then tell me the truth. Okay? So It's a little bit different than the one I just explained to you, but so 1/8 of the people will say yes, 1/8 of the people will say no, and the remainder will tell you the truth. They did this, and what they did is, so they phoned people and said, and it was illegal in those days, you know, to use marijuana, and they said, are you a marijuana smoker? You know, who would answer this on the phone, you know? But they got 40%. 40% answered that they would. Then they redid it with this flipping of the coin, with a randomized response, and now all of a sudden they got a 64% estimate of prevalence of marijuana use. So here it is. It increased the prevalence estimate by 60%. So here is one device that you can use.